Hi, my name is Razin Irshad bin Azrin and my student ID is 2023809968.
Hi and Assalamualaikum to my lecturer. My name is Ahmad Aidil Fikri bin Ahmad Fairuzi. My student ID is 2023892736.
Hi, my name is Nur Afika binti Abdul Nasir. My student ID is 2023450774.
So what is the safety equipment and technique? Before entering a workshop, it is important to wear the right safety gear. This helps protect you from getting hurt by tool machines, fire or sharp objects. Safety equipment keeps you and others safe while working. Always follow the safety rules and wear the required gear before starting any works. So first, safety glove. Why we need to wear safety gloves? To protect hands from cuts and burns. Sharp edges, hot surface or rotating tools can easily injure your hands. Second, improve the grips. Gloves help hold slippery or oily material more securely. And lastly, prevent skin contact with hazardous materials. Shield your skin from metal chips, chemical or rough surface. So next is safety goggles. This protect us from flying debris. During cutting, drilling, grinding or welding, tiny metal chips, spark or dust can fly into your eyes. Shields against chemical and fluid. Prevent coolant, oil or cleaning fluid from splashing into your eyes.
Next is safety shoes. Why we need to wear safety shoes is to protect feet from falling objects, sharp items, slips, electrical hazards and fatigue. And lastly is safety jackets. Safety jacket is to improve visibility, shield against sparks, heat, chemicals and prevent cuts or abrasions. Wearing all of this safety equipment is essential to prevent injuries, ensure safety and comply with workshop safety standards. Hey, so let's start the project. But firstly, we have to do all the measurements required for the first process using the right tool. The very first process is the cutting process. How? Firstly, clamp the metal plate tightly so that the metal plate doesn't move to prevent movement. Then, align the chainsaw to the marked lines on the metal plate and cut to the given dimensions. So why do we use cutting process before milling process? It's because for pre-shaping for machining. It removes excess material roughly and fast, saving time on the milling machine which is designed for precision. Next is prevent damage to milling machine. Using the mill for large cuts can strain the machine, increase tool wear and also reduce accuracy. There are many advantages of using cutting process. The first advantage is fast material removal, which chainsaws can cut through large pieces easily and also save time. The second advantage is portable and easy to use. We can bring chainsaws everywhere and it's also lightweight. The last advantage is low setup time. As for the disadvantages, first is low cutting precision. Chainsaws are not suitable for accurate or fine cuts. The edges are usually rough and uneven. The second is safety hazards. If not handled properly, chainsaws can be a very dangerous tool. Third is high noise and vibration. Chainsaws produce loud and noise-strong vibrations which can be uncomfortable and require protective gear. Come on, Dick, strong Dick. Next step is the turning process. So how? Prepare the machine, then put the workpiece, which is the metal rod, at the right spot. Then start the process. Why we use turning process is because to produce cylindrical shape production and high precision and also smooth surface finish. So, the advantages of using lathe machine. First is versatile machining, which can perform various operations like turning, facing, drilling, and many more. Second is high precision and smooth finish. It produces accurate cylindrical and conical shapes with excellent surface quality. Third is simple operation, which is easy to operate and control, especially for basic turning tasks. Then, the disadvantages of lathe machine is first, limited to rotational parts, which is only suitable for components that can be rotated around an axis. Second, time-consuming for complex parts, not ideal for parts with non-rotational or intricate features. Third, requires skilled operator. Precision work needs trained personnel to avoid errors or tool damage, so that the machine can be used for a long time.
Tembak, bunyi tembak. Ni modal tersebut.
After that, for the third step is drilling process. First, mark the metal plate with the dimension needed. And then, by using the correct drilling technique and wearing the safety equipment, the metal plate will be drilled according to the specification needed and the dimension marked earlier. There are many advantages and disadvantages in drilling process. The first advantages of using the drilling process is it will give a versatile machining output which refers to the broad range of capabilities in terms of its material diversity, process flexibility, and many more. Next, it also offers high precision and accuracy since it can handle both simple and complex geometries with tight tolerance. And lastly, smooth surface finishes can be produced, thus enhancing its surface quality. Apart from that, there are also disadvantages of the milling process, which are first, material wastage, since it can generate significant material waste. Second, skill requirement, since it requires highly skilled operators. And lastly, cost of the equipment, since it can be expensive to purchase and to maintain the machine. Next step is the milling process. The milling machine is utilized by placing the workpiece right on the machine and tighten the metal plate securely, and then move the rotating cutting tool by moving it in X, Y, and Z axis to remove material from the workpiece until the designated shapes and features are formed. The reason why we use milling is because it can help to create a complex shape, more efficient, and it can also give a smooth surface finishes. There are many benefits in utilizing the milling process, which are first, they can offer versatility since it can be used to create a wide range of shapes and features, including slots, holes, and intricate shapes. Next, it can also achieve high level set of precision and accuracy, allowing for the production of parts with tight tolerances. And lastly, is good surface finish, where milling can produce a very fine surface finishes depending on the type of milling and tooling used. Apart from that, there are also disadvantages of the milling process, which are first, material wastage, since it can generate significant material waste. Second, skill requirement, since it requires highly skilled operators. And lastly, cost of the equipment, since it can be expensive to purchase and to maintain the machine.
how we prepare the required equipment tool using small machine. Why we use welding, small welding? This is because it's better for dirty and rusty surface due to our workpiece is not in good condition. So lastly, what is the advantages and disadvantages of small welding? The advantages is portable and simple to set up, works on dirty or rusty surface, and low equipment cost. The disadvantages for small process is lower deposition rate, frequently change the electrode, and slug removal required.
So this is us trying to assemble our parts.
After the assemble, we weld the bottom of the turbine blade. So last step is finishing process. So how we prepare the equipment tool, which is hand grinder. We grind slowly on the adhesive metal surface until the surface becomes smooth and shiny. So why we use hand grinding machine? It's a more versatile access and quick and easy to use. What is the advantages and disadvantages of grinding process? The advantages is high surface finish, tight tolerance, works on hand materials. The disadvantages is slow material removal rate, requires skill and operation, and high equipment and wheel cost. The problem that we face during the turbine blade is miss the right measurement when drilling the middle hole. Make the hole bigger to fit all the component right. Next, the turning cutting tools hit the chuck holder of the machine and mess up of the middle of the shaft. So what is the solution is grind on the surface of the middle shaft until it looks cleaner and smoother, but outcome is still not perfect. Next, the end mill of milling machine broke twice while doing the process. Bought another one extra and used the last piece until the workpiece done. Lastly, the last screw didn't fit straight into the desired hole. We adjust the measurement on one of the turbine blade because it was too big from the others. So now we try to readjust the misalignment hole.
So how improper or poor materials can affect the machine? First is tool wear or breakage, which hard or abrasive materials can quickly dull or break cutting tools. Second, poor surface finish. Incompatible materials may lead to rough, uneven or defective surface. Third, increased rework or scrap. Incorrect materials often result in faulty parts that must be redone or discarded. Fourth, safety risk. Unexpected material behavior can cause kickback, debris or fire risk. Lastly is higher cost and downtime.
Lastly, for the discussion part, the improvement that can be made to solve for the first problem, which is inaccuracy of drilling hole measurement, are: first, steady drilling setup and workpiece stability, use high pressure coolant, and optimizing the drilling parameters.
So, what improvement can be made for the second problem is the tool collision during the turning. The improvement that we can make is recheck the tool setup and clearance before the operation, perform a dry run without cutting, set the tool height accurately.
Besides that, for the third problem, where end milling edge, chipping and tool breakage during milling can be improved by reducing the overall and initial feed rate, ensuring workpiece is clamped tightly and are stable, and lastly, decrease the axial or radial depth of cut.
So this is the fourth problem, which is screw misalignment and the improvements that can be made so that we didn't repeat the same problem.
Thank you. That's all from us. Assalamualaikum warahmatullahi wabarakatuh.